Okay, so computer glitched again. So much fun. Okay, so here we go, part 2. So I'm just going to kind of talk through my answers. I only lost about 10 minutes. So, again, if we're talking about transformations, everyone needs to be paying attention. If we're talking about similarity, it's exclusively for the my honors class. So for here, what I did was I looked at how do I get C to C to C prime. So I have this going to this. This is C right here. This is C prime. So what I realized I had to do to get the right orientation, flip it over the x-axis, and then move it 12 to the right. Number 2, yes, they're congruent. They actually give us everything, so you can actually use whatever congruency theorem you want. And then they ask for, remember, explain what transformation maps ABC onto DEF. I want you to remember that when we're talking about transformations and things like that, that any two congruent figures can be mapped onto each other with a series of transformations. But you can, if they're congruent, you can only use rigid transformations. That's translations, rotations, and reflections. If they're non-congruent, you can also use dilations and things like that. So dilations give you similar figures. So here I end up with hypotenuse leg, and then I use this line right here as a reflection line in order to get ABC. Because see here, I want A has to go over to D right there. Okay, so I can't rotate it around and get it to match up, because if I rotated it, like spun it, then I'd end up with that triangle right there. And that doesn't match up. Or rather, I'd end up with this right here if I rotated it. And that doesn't match up. So I need to reflect it. 3, bisects, remember, means cut in half. So it cuts both this angle in half and this angle in half, and that gives us angle side angle. Going back up to number 4, what I did here was I went, okay, the whole thing needs to move over 5, up 1, and I picked 2 points to make sure that that worked. Because the last thing I want to do is just assume that for 1 point it works. Which of the following series of transformations will produce congruent figures? And this is what we were just talking about. Because they're congruent, I can only use rigid transformations. Rigid transformations are translations, reflections, and rotations. So notice that the 3 I crossed out, A, C, and D, all have dilations in them. Dilations do not, let me have a sip of water here, guys. Dilations do not give you congruent figures. They give you similar figures. Okay. Then 6, is it true, and this will actually, is it true that those two are congruent? Yes. And so what we really want to do here is, I know that we have all the markings, but remember, order matters. So we need to go, we go 2 to 3 to 1 here. A to E to B. So D to E to C needs to follow that same pattern. Does it? Yes, it does. Therefore, we have side-side-side congruence. Moving on. So these are isosceles triangles. Notice here that these sides here are 1 and 1. We also know that because they're isosceles triangles, the base angles have to be the same. And so we just look for that right there. And so we would then say which triangle is congruent to ABC. We need to make sure that we're following the right set here. So we go I, G, H. What kind of triangles are there? They're isosceles. Number 8, given points, A is 5, 2, B is 2, 0, C is 14, 0, D is 4, 3, E is 9, 3, and F is 9, 15. Show that ABC is congruent to DEF. So, this is going to be a bit. So, we have 3 sides to each triangle. We have A to B, B to C, and C to A. So what we're going to do here is we're going to show this using the distance formula. Distance is, y is distance s, I don't know, square root of x2 minus x1 squared plus y2 minus y1 squared. This is a form of the Pythagorean theorem. So I have A here, B here, and C here. So this is going to be 2, 5. Sorry, I'm going to have, let me fix that. So I have 3 sides. I have AB, BC, and AC. So here, that gives me 2, 5, and 2, 0. This gives me 2, 0, and 14, 0. And this gives me 2, 5, and 14, 0. Luckily, we have a lot of straight lines here, so if I was drawing this on a graph, it would be a lot easier. Not a lot easier, just a lot. You'll see what happens. So this row right here is my x1, y1s. The other ones are my x2, y2s. So let's get going on distance. So this is going to be the square root of, now this is what I'm talking about being easy, 2 minus 2 squared plus 5 minus 0 squared. 2 minus 2 is 0. 0 squared is 0. So this is just going to be the square root of 5 squared, which is 5. This right here, square root of 14 minus 2 squared plus 0 minus 0 squared. 0 minus 0 is 0. So this just turns into 12 squared. Square root of 12 squared equals 12. This right here, we're actually going to have to do some math, people. 14 minus 2 squared plus 0 minus 5 squared equals the square root of 12 squared plus negative 5 squared equals the square root of 144 plus 25, which is the square root of 169, which is 13. So the length of these triangle sides are 5, 12, 13. So now we need to do the same thing with DEF. So we have DE, which is going to be 4, 3, and 9, 3. We have EF, which is going to be 9, 3, and 9, 15. And then we have DF, which is going to be 4, 3, and 9, 15. So here again, this is going to be my x1, y1. This is going to be my x2, y2. Let's get after it. So this side right here, square root of 9 minus 4 squared plus 3 minus 3 squared. 3 minus 3 is 0, so that cancels out. 9 minus 4 is 5. So we have the square root of 5 squared, which is just 5. Here we have 9 minus 9 squared. That's going to be 0. Going to disappear. Plus 15 minus 3 squared. 15 minus 3 squared is 12. 12 squared root of 12 squared is 12. So notice again we have 5, 5, 12, 12. And I'm assuming that this next one's going to be 13. But let's show the work. We have 9 minus 4 squared plus 15 minus 3 squared gives me the square root of 5 squared plus 12 squared, which gives me the square root of 25 plus 144, which is the square root of 169, which is 13. So what we just did was we found the length of all three sides and showed by our math skills that they are indeed side congruent. Are these shapes similar? So number 9, if you're in regular geometry, go ahead and skip this one. So similar, what we're doing here is, so we know that, so one, we can look at the angles. We know that these two angles are the same and these two angles are the same. Notice that these angles don't match up. So these angles aren't the same, these aren't the same as these two. So we know, how do we know? Angles are not congruent. The other way we could do it is we could set up the sides. All four of these sides are equal, meaning that they'd have to be proportionate to all four of those sides. We have two sides here and two sides here that are different lengths, so they can't all be proportionate. So you could also say no, sides aren't proportionate. So again, number 10, similarity, that thing right there. So we're talking to the honors class. Find RT and HI. Okay. So this is kind of, there are a couple ways to do this. We can be super like literal about this and go, okay, we know that the relationship between 24 and 4 equals the relationship. So for RT, between JI and RT would be X and 4. Cross multiply, 4 times 24 is 96, equals 4x, divide by 4, we get x equals 24. We can also look at this and go, hold on a second, guys. This is a isosceles triangle. For it to be similar, they need to be proportionate. So that's also an isosceles triangle. Now we can go here, 24 divided by 4 is the same thing as 42 divided by HI. So we're going to call that x here. Couple different ways we can do this. Again, we can cross multiply. 24x equals 168. Divide both sides by 24. And you get x equals 7. The other way you can do that, 24 divided by 4 is 6. 6 equals 42 over x. And you go, 42 divided by what equals 6? And you go, hey, that's 7. So x has to equal 7 in order for this to equal 6. Either way, HI is 7. Number 11, the figures below are similar. Find the perimeter of figure 2. So what we do here, remember, we know that if the figures are similar, the perimeters are similar. So that ratio of the sides of 2 to 5 is going to be the same as the relationship of the perimeters, 12 to x. Cross multiply, we get 2x equals 60. Divide by 2, and we get x equals 30. So the perimeter of this bad boy is 30. Again, similar figures, so if you are in standard geometry, keep moving. The values of x and y in the figures below. So we know that these two we have here are similar. So we know that the relationship between 22 and 14 is going to be the same as between these two bad boys. Equals y plus 15 over y. Cross multiply, 22y equals 14 times y plus 15. 22y equals 14y plus, let's do some math, 14 times 15, that's a 2, that's a 7, that's a 14, that's 210. Plus 210. Subtract 14y from both sides. I'm going to get 8y equals 210 divided by 8. Y equals 216. Ick. Is that right? (22 over 14) is what was 4y. So 22y is 14y. I'm going to do this again and hope that I'm wrong. Nope, it's 210. It's so stupid. I don't like it. 26.25. And then here we'd have 22 over 14, which if we pull a 2 out is 11 over 2, equals 30 plus x over 30. So we get 330 equals 60 plus 2x. Subtract 60. That's going to give me 270 equals 2x. Divide by 2. And we get x equals 11 over 7. I'm like, this is not making sense. And that's because I did it wrong. It's 11 over 7. That's going to be 210 plus 7x equals 330. Subtract 210. It's 7x equals 120. Divided by 7. We get x equals we're just going to go 17.1. Stupid. I don't like that at all. Anyway. What's the height of the tree? Okay, so these are specific similarity problems, but they're not too bad. So we know that this is 2 and 3, and these two triangles are similar because these two lines are parallel. And so what we're looking for is the height of the tree. So the ratio of 30 to 3 is going to be the same as the ratio of x to 2. Cross multiply, 3x equals 60, x equals 20. So it's a 20-foot tree. 14, find the values of a and b. I'm getting nervous about this, so I'm going to stop this and save it and start the next one on point 4.